Okay, so this is the checkpoint. Complex numbers. Okay, so a complex number is written in the form a plus bi, where a is the real number and b is the complex number. So b and I. So then we have a plus bi. So we call the a the real, and the b, the number in front of the I, is the imaginary. Okay, so for this first question, if we have 3 plus 2i, part A of the question wants to know what is the real part of the complex number. So the real part, we said, is the number that doesn't have the I attached to it. So in this case, 3 would be our real number. And then it wants to know B, what is the imaginary part? So the imaginary part is only the number in front of I. So that's B, which in this case is the 2. So then the real part is 3, and the imaginary part is 2. Any questions on this first problem? Let me check the chat. Okay, and catching up in the chat. No, this is not the checkpoint we've already done. This is the one due on September 16th. That's due tomorrow. So the checkpoint for complex numbers. Okay, I don't see any questions yet. All right. So all imaginary numbers can be written as complex numbers in the form a plus bi. For the number 5i, what is the value of a and b? So if we want to write it in the form a plus bi. How can we write it in the form a plus bi? So if we have 5i, we know that that is the complex part. So we know we're going to have 5i here. The real part, well, the real part is just 0. So a would be 0 and b would be 5. Any questions on this one? Yes, very good, Savannah. Thank you. Yes, a equals 0 and b equals 5. All right, moving to the next one. Which expression represents the number the square root of -16 minus the square root of 25, rewritten in a plus bi form? So you're going to have to do some simplifying. So if we have the square root of -16 minus the square root of 25. So simplifying square roots, we can simplify the square root of a negative number using our imaginary numbers. So the square root of -16 would be -1 times 16. And then the square root of -1 is I. And then the square root of 16 is 4. And then we have minus the square root of 25, which we all know is 5. So if we put it in a plus bi form, we would get -5 plus 4i. Yep, exactly, Caleb. Very good. Any questions on this problem about simplifying our square roots? Okay, we'll keep moving along then. Okay, which expression represents the number 12.3 rewritten in a plus b? Okay, so since we've gone through this, I'm going to let you guys do it and then send me your answers in the chat. So we're trying to rewrite 12.3 in a plus bi form. So go ahead and do it and send it to me. See if we've got the hang of that. I've got one. Anyone else? I've got two. Yep. Here they all come. Exactly. Right. So 12.3, that's a real number. So if we want to write it as a complex number, we would just do 12 plus 0i. Exactly. Oh, 12.3, sorry. So 12.3 plus 0i. Good, you guys have got it. Any questions before I move on? Okay, now we're going to match the numbers that have the same value. So we're just going to simplify these negative square roots. So let's start with the square root of -5. So you have to expand first. And so we get -1 times 5. Now we know that the square root of -1 is I. We don't know what the square root of 5 is. It's some decimal. So we're just going to leave it. And so here we go. Then we need to do the square root of -36. Go ahead and try that one. And then send me your answer in the chat. Yep, you guys have got it. That's the square root of -1 times 36. Well, the square root of 36 is 6. The square root of -1 is I. So that is 6i. Very good. And the last one, go ahead and do the square root of -8. So careful, I see lots of 4s. Let's take a closer look. So if we do the square root, let's expand it first. So the square root, we know it's a -1, and then to get 8, we would do 4 times 2. So the square root of -1 is I, we know. The square root of 4 we can do, which is 2. So that's going to be 2i, and then we're still left with square root of 2. Any questions on how I got that? Since I know some of us got a different answer. You guys see how we got the 2 instead of the 4? Okay, perfect. All right, any questions on these before we move on? Okay, getting into the fun stuff. So what are the solutions to the equation x squared plus 4 equals 0? So x squared plus 4 equals 0. So we're solving for x, which means we need to get rid of this plus 4. So we subtract 4 from both sides. So x squared equals -4. We want to get x. We don't want to know what x squared is, so we have to take the square root of both sides. So x equals, and remember when we take the square root, we get a positive and a negative. The square root of -4. And so the square root of -4 is -1 times 4. And so the square root of -1 we know is I, and the square root of 4 is 2. So then we get x equals positive 2i and x equals negative 2i. So looks like it would be that one. Any questions on this problem? Okay, Roman completed the square to solve the equation. 0 equals -x squared plus 6x minus 15. Okay, so go ahead and look over Roman's steps and then tell me if he made a mistake, and if he did, where he made that mistake. Was it step 1, step 2, step 3, 4, 5, 6, or 7? Got one person. Let's see, I'm not going to say yet, Caleb. Okay, Caleb, will you, oh, Calliope just said it, exactly. So, right, in step 6, he should add 3 to both sides, right? He subtracted 3, but it was x minus 3, so then you're gonna get x minus 6, not x equals -3 plus I radical 6. So that is correct. Yes, Caleb, you were right. Very good. So in step 6, he should have added 3 to both sides of the equation. Very good. And these, sometimes it's hard to always look at it. So if you're ever like in a high stakes testing, just don't even look at the steps. I would do it on your own and then compare your steps to his steps, because otherwise it's easy to look at it and think, oh, he did everything right, when he really didn't. Okay. What are the solutions to the equation x squared plus 4x plus 17? So we're going to be completing the square. So like we talked about last week, first we need to subtract 17 from both sides so that we can complete the square. And then to find our C term, remember we have to divide the B term, 4 divided by 2, and then square that. So 2 squared, which is 4. And if we add 4 to the left side of our equation, we also have to add 4 to the right side of the equation. Now our perfect square here is x plus 2 squared equals -17 plus 4, which is -13. Any questions so far? All right, and now we can take the square root of both sides. And so we have x plus 2 equals plus or minus the square root of -13. And then we're trying to isolate x. We have to get x all by itself. So we will subtract 2 from both sides, which leaves us with x equals -2 plus or minus the square root of -13. So we're almost there. Now we just need to simplify our negative radical. So -2 plus or minus the square root of -1 times 13. And so we know the square root of -1 we can take out because that is I, and then we're still left with a square root of 13. So x equals -2 plus or minus I radical 13. -2 plus or minus I radical 13, just like that one. Any questions on that one? Very good, Calliope. All right, use the discriminant b squared minus 4ac to determine which equation has complex solutions. Okay, so this one requires a lot of work. So we'll get started because we are running out of time. So if let's look at the first one, x squared plus 2x plus 5. So the good thing is it looks like there's only one. So to determine which equation has complex solutions. So first we need to identify A, B, and C. So A, remember, is the number in front of x squared, which would be 1. B is the number in front of x, which is 2. And C is the one without an x, which is 5. And now we have to plug that into b squared minus 4ac. So we have b, which is 2 squared minus 4 times a, which is 1, times c, which is 5. Any questions so far? So then now we just simplify. 2 squared, that's 2 times 2 is 4. -4 times 1 is -4. -4 times 5 is -20, which gives us -16. And so that, yay, we didn't have to, they put it in a nice order. Last night when I was going over them, it wasn't nicer. So we already found the complex solution because we got -16.
So I was doing this and I figured out, I mean, it's not, so there is this thing that if the center one is small, if it's lower, yeah, if B is a low number and the other ones are large, so they can't be negative because then you'll get a plus sign there. So if only one of them is negative, then you'll get a plus sign. So the really qualifying things, I figured this out because I was like, I can try and, because mine came in a different order than that. So
right. And it was a lot of work.
Yeah, the answer was the third one when I did this. So I was like,
yep.
I could just figure out, I could try and figure out which one it is and then do the work for that one. And if it's correct, then I can just move on without having to do the work for all of them.
Yeah, very good. Okay, now we're going to use quadratic formula to find the solutions to, let's see, what number are we on? 10. Okay, and we have 4 minutes. So we have x squared plus 8x plus 25 equals 0. And so again, we need to identify A, B, and C. So A is 1, B is 8, and C is 25. And then we're just going to plug into our quadratic formula, which they gave us right there. So -b, which is 8 plus or minus the square root of b squared, which is 8 squared minus 4 times a, which is 1, times c, which is 25. All over 2 times a, which is 1. All right, and then that's the hard part. Now we just have to simplify. So we get -8 plus or minus the square root, 8 squared, 64. -4 times 1 times 25 is -100. divided by 2 times 1, which is 2. Any questions so far? I know I'm going fast now because we're almost out of time. Okay, then we just keep simplifying. 64 minus 100 is negative 36 divided by 2. Then we get negative 8 plus or minus. So we know that this is negative 1 times 36. So the square root of 36 is 6. The square root of negative 1 is I divided by 2, which we can now reduce. So negative 8 divided by 2 is negative 4 plus or minus 6i divided by 2, which is 3i. So negative 4 plus or minus 3i. Any questions on number 10? All right. Finding the solutions again. We have 3x squared minus 4x plus 7 equals 0. So we're going to plug in A, B, and C. So A is 3, B is negative 4, and C is 7. And then we plug it into our quadratic formula. So negative B, which is negative 4 plus or minus the square root of B squared, negative 4 squared minus 4 times A, which is 3, times C, which is 7, all over 2 times A, which is 3. Then we just simplify. So a negative 4 becomes positive 4 plus or minus negative 4 squared, which is 16. Negative 4 times 3 times 7 is negative 84 divided by 6. We just keep simplifying. So 16 minus 84 is negative 68 divided by 6. Then we need to simplify the square root of negative 68. So that is negative 1 times 17 times 4. So the square root of negative 1 we know is I. And the square root of 4 we know is 2. So those can come out of the radical. And then we're left with a radical 17. So now we have 4 plus or minus 2i radical 17 over 6. This is a marathon problem. You guys still with me? Okay, and then we can simplify these. So they're all divisible by 2. So we get 2 plus or minus I radical 17 over 3. Okay, and last one. Aurora used the quadratic formula to solve the equation as follows. Did she make a mistake? If so, where? So let's see. Does anyone see a mistake that she made? So let's see, A would be negative 2, B would be 6, and C would be negative 11. So we have negative B plus or minus the square root of B squared minus 4 times A, which is negative 2, times C, which is negative 11, divided by 2A, which is, so she set it up correctly. 6 squared is 36. Negative 4 times negative 2 is positive 8. Positive 8 times negative 11 is negative 88. Divided by negative 4. That looks okay. 36 minus 88, is that negative 52? Yes. Yeah, if you guys have a meeting, go ahead. You're free to go. And I have some kids here for my next 1 o'clock meeting, so. And then let's see, the square root of 52, that would be 13 and 4. So since you guys were troopers, I'll just let you know, she didn't make a mistake. And then you can go ahead and submit it. And then I'm gonna let my geometry students in. So there's your checkpoint. That's due tomorrow. Any questions from anyone in Algebra 2 before you guys go? All righty, thank you guys for coming. Hope that was helpful. If you have any questions, you can email me. And thank you guys for coming. Have a good week.